But we are going to move on to our second last topic for today, which is calculus. Calculus is probably one of the most important things you can remember from year 11 for year 12. Honestly, probably 60% of the year 12 course is calculus. So super important to know what's going on here. And calculus is kind of a good topic in the sense that if you know how to approach each of your questions, it's super easy to get those questions right every single time, because there's one approach for each question type that will work. So the sort of questions that if you do enough practice on, you can guarantee those marks in your exam. Okay, so I guess we're starting with just an introduction to differentiation. So the gradient of your function is equal to the gradient of the tangent at the point of contact. I'm just going to quickly do this, just so you guys can see a graph. So the gradient at this point is just equal to the gradient of the tangent at that point. Okay, so one way you can do this is by looking at the first principles. With the first principles, I wouldn't stress too much about actually memorizing this formula. Typically, if any question is to come up with first principles, you will get given the formula at the beginning of the question. So I wouldn't stress too much about remembering it. And if you ever get into an exam and you don't get given this formula, but but you have to use it, the question specifies you have to do it by first principles. An easy way to check, or I guess to sort of start guessing, is to remember that you have to have H, and that if you can work out what the differentiation of the question is beforehand, then you can sort of start guessing of how you can end up at that answer using your first principles. So yeah, hopefully you guys are familiar with your differentiation by first principles. Your other common differentiation rules are here. These rules are on your formula sheet, so you don't really have to stress about remembering them. You sort of have to remember about how to use them. So your differentiation of C is always equal to 0. To differentiate x to n, it's equal to n x n minus 1. To differentiate two functions that are being multiplied together, it's equal to f dash x times times g of x plus f of x times g dash x. Your quotient rule, if you're looking at two functions being divided by one another, g of x, or this one, your quotient rule, super important that you get these terms the right way around, okay? When you're looking at your product rule, doesn't really matter whether you do f dash x first or g dash x first. With your quotient rule, it does. It really does matter which way you do this. Okay, so you have to remember to put your denominator as the first term, and then your numerator differentiated minus your numerator times your denominator differentiated, all over your denominator squared. Okay, super important that you get this the right way around, because otherwise you're going to get the wrong answer. And then you've just got the chain rule as well. Okay, so don't stress about remembering these. They're on your formula sheet. Just know how you're meant to use them, what each of them means. And yeah, I guess that's all you really need to know about them. Yeah, just be familiar with them, I guess. Do lots and lots of practice questions using all of these different rules, and you will be absolutely set for your differentiation. So I guess the first application you do of differentiation is in year 11. And essentially you use differentiation to allow you to solve for the gradients of a curve at certain points, and to find the maximum and the minimum points, as well as find where the curve is stationary, where it's increasing, where it's decreasing. And then you can use that to apply to real life problems. This application to real life problems comes in a lot more in year 12. So if you can become super familiar with how to find them, you'll be super set in year 12 when you learn about the application of them through optimization. You guys wouldn't have heard the term optimization before, and that's fine because you don't need it until year 12. So essentially, the important principles to look at with differentiation is if f dash x is greater than 0, Then our curve is increasing at a point. So we can see it here, f dash x greater than 0 at any of these points, and f dash x will be greater than 0 at any of these points, which means our curve is increasing, which essentially, if our curve is increasing, we've just got positive gradients. Okay? Opposite is true for if the curve is decreasing, f dash x will be less than 0, so you can see that at all the points where we've got a negative gradient. And then at the points where our curve is stationary, f dash x is equal to 0. So we can see that at our maximum here, and then our minimum as well. So you want to be remembering these things in blue. They are super duper important. So make sure you've got them written down somewhere, or that you've got them memorized or something. If for whatever reason you forget, increasing means positive gradient. I feel like that's pretty, like those two words, like increasing and positive are linked. Decreasing, negative gradient. Stationary is flat. The tangent at that point would be flat. Okay, so I guess the last little bit of calculus we're actually going to be looking at today is how to find the equation of the tangent or the normal. So these are a really standard question type, really, really common. They get asked all the time. And this is one of those calculus questions that they have the exact same structure every single time. So if you can follow this structure, you'll get these questions right every time. They do come up again in year 12, like you do get these exact same question types again. So if you can get really good at answering them now, you'll be doing yourself a mad favor for next year. So first step is to differentiate, find the differential of f of x, if it's f of x or g of x, a of x, whatever they give it to you as. So then in the question, they'll give you some coordinates. You want to substitute the x coordinate into the derivative you found to find the gradient at that point. Okay, once you've found the gradient, the next thing you want to do is to substitute that x coordinate that they've given you in the question back into your original function, not your differential, but your original function to find the y coordinate. That's only if they haven't given you the y coordinate. Sometimes they'll be nice and you'll get given like actual coordinates, you'll get x and y. But if they haven't been so nice, you want to put the x coordinate they've given you back to the original function to find a y coordinate. And then all you need to do is use the point gradient formula to obtain the equation of the line. So if you guys don't know what the point gradient formula is, it's the formula where you do y minus y1 equals m in brackets, x minus x1, close the bracket. So you've got y minus y1, which is the y coordinate you found, equals m, which is the gradient we found, x minus the x value we found that gradient at. Then obviously if you're finding the value of the normal, you use the reciprocal of your gradient. And then you can use the same x and y coordinates. And yeah, that is how we find the equation of the tangent or the equation of the normal. Like I was saying, these are super common question types, so get super familiar with this. If you guys want to write this table down, take a screenshot of it, take a photo of it or anything, I would definitely recommend doing that because these are super common. And if you can nail how to answer them now, you're guaranteeing yourself like 3 or 4 marks, at least in your exam. Okay, because these questions, when you get them, are usually worth a fair few marks. You usually get 1 mark for finding the differential, 1 mark for finding the gradient, and 1 mark for finding the value of the line. If they haven't given you the y coordinate, you might get a mark as well for being able to find the y coordinate. So I can almost guarantee that something like this is going to come up in every single one of your calculus exams. So that's a guaranteed 3 or 4 marks at the very least.